Hello electrical engineers, this is Mo, your instructor. In this lecture, I'll explain the difference between type B, type C and type D circuit breakers. So let's start. We have two main categories for circuit breakers: miniature circuit breakers (MCB) and molded case circuit breakers (MCCB). Circuit breakers are electrical devices designed to protect electrical circuits from damage caused by excess current. They play a crucial role in ensuring the safety of electrical installation by interrupting the flow of current when it exceeds a certain threshold. This helps prevent overheating and potential fires that could result from prolonged exposure to high currents. Circuit breakers are often described as thermomagnetic devices. This means they use a combination of thermal and magnetic mechanisms to detect and respond to abnormal current conditions. The thermal component senses overheating caused by prolonged high currents, while the magnetic component responds to sudden and high magnitude short circuit currents. Circuit breakers must be capable of handling normal currents during regular operation, carrying the current without interruption. However, in abnormal conditions such as short circuits or prolonged overloads, they should be able to interrupt the flow of current swiftly to prevent damage to the electrical system. Miniature circuit breakers are commonly used in most electrical installations to protect final circuits. These circuits typically supply power to outlets, lighting, and other end-user devices. Miniature circuit breakers or MCBs are designed to handle lower current capacities and are more compact in size compared to other types of circuit breakers. Molded case circuit breakers are larger circuit breakers suitable for protecting larger distribution circuits. Distribution circuits are responsible for carrying electrical power to various parts of a building or facility. Molded case circuit breakers or MCCBs are capable of handling higher current capacities and are often employed in industrial and commercial settings. In summary, circuit breakers, whether miniature or molded case, are crucial components in electrical systems. They ensure the safe and reliable operation of electrical circuits by responding to abnormal conditions and interrupting the flow of current when necessary to prevent damage and hazards. The nominal rating of circuit breakers denoted by the symbol I subscript N related to the continuous service under specified installation conditions. This means that the normal rating represents the maximum continuous current that the circuit breaker is designed to handle under normal operating conditions without tripping. Additionally, we have cables and conductors. These cables and conductors are used to transmit the electrical power and they have the capability to carry higher currents for short periods without causing permanent damage. The nominal rating of a circuit breaker is the maximum current that it can carry continuously under specified conditions. This is an important parameter in ensuring the proper and safe functioning of the electrical system. The nominal current rating I subscript N is determined based on factors such as the type of load, ambient temperature, and other installation conditions. It reflects the capacity of the circuit breaker to handle the continuous electrical load without tripping. Cables and conductors used in electrical installations are designed to have a certain current carrying capacity, CCC. This capacity is influenced by factors such as conductor size, insulation type, and ambient temperature. While the nominal rating of a circuit breaker is specified for continuous service, cables can tolerate higher currents for short periods without suffering permanent damage. This ability to handle temporary overloads is known as the cable short-term current carrying capacity. In practical terms, electrical systems may experience short-term overloads due to transient events or temporary increases in power demand. The flexibility of cables to handle such short duration overloads allows for some degree of tolerance beyond the continuous rating. However, it is crucial to ensure that these overloads are within the limits specified by the cable manufacturer and industry standards to prevent any damage or degradation over time. In summary, circuit breaker nominal rating indicates the maximum continuous current they can handle, while cables have a short-term current carrying capacity that allows them to withstand higher currents for brief short without causing permanent damage. The current carrying capacity of a cables is greater than the nominal rating of the circuit breaker. We have three types of circuit breakers: type B, type C, and type D. The key characteristics that distinguishes these types is the level of overcurrent at which they trip or disconnect. This tripping is usually determined by a magnetic device within the circuit breaker. The value of current at which each of circuit breaker disconnects instantaneously is referred to as I subscript A. So I subscript A is the instantaneous current trip. Type B circuit breakers are designed to trip at between 3 and 5 times the rated current I subscript N. Type B circuit breakers are a specific category of circuit breakers designed to provide protection against moderate overcurrents. The tripping characteristics of type B circuit breakers means that they will disconnect the circuit when the current exceeds a certain threshold, and this threshold is expressed in terms of a multiple of the rated current I subscript N. The type B circuit breakers trip at levels between 3 and 5 times the rated current I subscript N. This means that the circuit breaker will instantaneously disconnect the circuit if the current reaches a value that is 3 to 5 times the normal or rated current. Type B circuit breakers are commonly used in domestic circuits and commercial applications where there is typically no significant inrush current to cause the circuit breaker to trip. Inrush current refers to a sudden or temporary increase in current that can occur when electrical equipment is switched on. Since type B circuit breakers are not as sensitive to inrush current, they are suitable for applications where this is not a common occurrence. Example: a 32 ampere type B circuit breaker, the magnetic trip could be set at 160 ampere. This corresponds to the instantaneous trip current I subscript A equal to 5 times the rated current I subscript N. So 5 times 32 is equal to 160 ampere. In summary, type B circuit breakers are designed to trip at a level between 3 to 5 times the rated current, making them suitable for application where there is no significant inrush current. Type C circuit breakers are a specific category of circuit breakers designed to provide protection against higher levels of overcurrent compared to type B. The tripping characteristics of type C circuit breakers means that they will disconnect the circuit when the current exceeds a certain threshold, and this threshold is expressed in terms of a multiple of the rated current I subscript M. The type C circuit breakers trip at a level between 5 to 10 times the rated current I subscript N. This means that the circuit breaker will instantaneously disconnect the circuit if the current reaches a value that is 5 to 10 times the normal or rated current. Type C circuit breakers are commonly used in commercial applications where there are motors or fluorescent luminaires. These devices may exhibit inrush current when they are switched on, and the Type C circuit breakers are designed to accommodate and tolerate such inrush currents. Inrush current refers to a sudden and temporary increase in current that can occur when electrical equipment with motors or fluorescent lights is activated. For example, a 32 ampere Type C circuit breaker, the magnetic trip could be set at 320 ampere. This corresponds to IA equal to 10 times I subscript N, where I subscript A is the instantaneous trip current and I subscript N is the rated current. In summary, Type C circuit breakers are designed to trip at a level between 5 to 10 times the rated current, making them suitable for commercial applications where there may be motors or fluorescent luminaires with inrush current. Type D circuit breakers are a specific category of a circuit breakers designed to provide robust protection against very high levels of overcurrents. The tripping characteristics of Type D circuit breakers means that they will disconnect the circuit when the current exceeds a certain threshold, and this threshold is expressed in terms of a multiple of the rated current. The Type D circuit breakers trip at a level between 10 to 20 times the rated current I subscript N. This means that the circuit breaker will instantaneously disconnect the circuit if the current reaches a value that is 10 to 20 times the normal or rated current. Type D circuit breakers are industrial grade units specified for applications where there are large inrush currents. For example, such applications include industrial motors, X-ray units, and other equipment that may experience a significant inrush current during operation. For example, a 32 ampere Type D circuit breaker, the magnetic trip could be set at 640 ampere. This corresponding to 20 times the nominal current, so the instantaneous trip current 640 ampere equal to 20 times the nominal current 32 ampere. So 32 times 20 equal to 640. In summary, Type D circuit breakers are designed to trip at a level between 10 to 20 times the rated current, making them suitable for industrial applications where large inrush of current are expected.